This is a demonstration of real-time global illumination based on a paper published in the ACM Transaction on Graphics at SIGGRAPH 2024, proposed by Liu et al. From the University of California, San Diego. The paper is titled Real-Time Path Guiding Using Bounding Voxel Sampling, and the algorithm proposed in this paper is called VXPG, which stands for Voxel Path Guiding. The core idea is that instead of randomly guessing where light comes from, we can inject irradiance, which is incoming light energy, into a 3D voxel grid in every frame and use that to guide our samples towards bright regions. Everything runs in OpenGL using vertex, fragment, geometry, and compute shaders, and at a 1080p resolution. Each frame runs 9 passes in order: a shadow map, voxelization, a G buffer, light injection, CDF construction, path guiding, optional ReSTIR resampling, denoising, and finally deferred shading to composite everything together. Here is VXPG enabled with balance settings, which is the default in this case. You can see indirect light, which is a light that has bounced off all the surfaces, so it's bouncing off Suzanne and the different shapes, and then onto the floor, and then back to the model, which can be seen as I change the colors here. By switching to this direct only mode, this removes all contributions of indirect lighting, and this is a plain BSDF sampling, so only these direct lights and the shadow. Now I'm switching to GI boosted, which amplifies the indirect light strength, making the global illumination contribution clearly visible. This algorithm is routing samples towards the high irradiance voxels in the grid. Enabling the voxel overlay shows each populated voxel as a wireframe box. Only geometry visible to the camera receives irradiance, and this prevents lighting surfaces that are occluded from the camera's view, which also reduces the amount of compute required for globally illuminating the scene. At a low resolution, like 8, the axis-aligned bounding boxes fitted to the geometry inside each voxel are large and loose, so many candidate samples get rejected. But at higher numbers like 64 cubed or even 128 cubed, the bounding boxes are tight to the geometry, giving fewer rejections and a cleaner result overall. The temporal alpha slider controls the exponential blend between the current frame and the accumulated history. At 1, there's no accumulation at all, so the output is raw 1 sample per pixel, which is very noisy. Back at 0.1, we heavily weight history for a smooth result, and moving the light source shows how the accumulation slowly catches up. Now, I'm enabling ReSTIR, which stands for Reservoir-Based Spatiotemporal Importance Resampling, which reuses light samples from neighboring pixels and previous frames. It takes VXPG's candidates as input and reduces noise further. Increasing the spatial taps increases how many neighbors contribute per pixel. Then there's this Gaussian denoiser that applies a weighted pixel blur to the indirect buffer, and increasing the blur sigma smooths noise but starts to bleed across depth edges, so the moderate value works best.